Welcome. This is the ISRO exhibition where we are actually showcasing the different type of satellites and launch vehicle which are being developed by ISRO. These satellites and these launch vehicles are meeting the Indian requirements in the field of telecommunication, in the field of DTH operation, weather monitoring, the cartographic application, oceanography application or astronomy. So, for example, right now where I am standing here, this is a OceanSat model. OceanSat is a satellite which is dedicated to the study of the oceanography. What happens in ocean? There are a lot of fishes in the ocean and our fishermen are depending upon the catch what they get from the sea. How do they know that where that fishes are there? So, that is depend upon that shovel, that what is that greenery, what vegetation is there in the sea. So, this satellite is capable of monitoring the vegetation level in the sea, so that we can get an estimate of where maximum fishes are available. This kind of data can be supplied to the fishermen so that they can go and catch the fish from there. Apart from this, this is a satellite which is also taking care of what type of phenomena is happening in the ocean, like for example cyclone, typhoon, etc., how their movement is taking place, and that those things are being monitored and been collected and sent back to earth, so that we are in a position to have a disaster management. Some time, suppose typhoons are coming, we will be knowing that information much advance, maybe around 2 days in advance, so that we will be able to evacuate the people from that dangerous area. So, that way we will be able to know that where that typhoon or cyclone are going to hit our borders. So, we will be able to evacuate all the people from there and save the lives. So, this is that satellite meant for the oceanography and any events happening in the ocean. This is another satellite. Basically, it is a GSAT. It is a geosynchronous satellite which are being used for communication purpose as well as DTH operation. This satellite is rotating in geosynchronous orbit. That means it is a synchronous with the earth speed. As the earth rotates, satellite also rotates, so its position always will be stationary with respect to the earth. So, this kind of satellites are used for weather monitoring, so that we will be knowing what type of clouds are there, whether clouds are having water in them or not, as well as it will be able to give you telecommunication signals like mobile telephony as well as internet. It will be also used for your DTH operation. That means whatever like television people are watching, that signals can be obtained from there. Okay. Now, we are coming to another types of satellites which are there in the kitty of ISRO. This is resource set and this is a RI set. Basically, this is a like radar imaging and this is a resource set. Resource set means earth is having various type of resources, like different type of minerals are available, water is one resource, vegetation is another resource. So, these satellites are meant to map the resources available on earth, where we are having water in sufficient quantity, how the rivers are moving, they are getting diverted, or where deforestation has taken place, where forestation has taken place, how much forestation has taken place. All those things can be monitored using these kind of satellites. Similarly, radar imaging means it is able to cross that whatever is our clouds. Clouds also we will be able to see, so that cloud studies also can be carried out using these two satellites. Now, we are coming to another satellite which is Cartosats. Cartosat is a cartographic satellite, that means it is able to take the stratigraphic image of the earth terrain. So, we will be able to know what are the terrain things, what are the particles in the terrain, any movement is taking care or not. So, this kind of things can be utilized with the Carto satellites. Now, you might have seen several satellites here, all satellites in space. So, they get perturbed. How they will be maintain their attitude? Attitude means looking towards the earth. How they are able to maintain it? It is the help of two things. One is a sensor, second is actuator. Sensor means that it senses any tilt taking place in the satellite, how much tilt is taking place in satellite, and based on that how to correct it. So, for that we have different types of sensor, like initial reference units are there, which is having a gyroscope mounted on it. Gyroscopes are the instruments which are used to measure the rate. Rate means any kind of tilt taking place in the satellite. How to correct it? For that we have different type of actuator. This is called reaction wheels. We have multiple reaction wheels, from nano, micro, reaction wheel, then momentum wheel. Depends upon the size of satellite. The actuator size also depends, that how much actually torque is required to maintain and bring back in this position. So, for that we are using nano reaction wheel, means it is for nano satellite. Right now, what trend is going on. Earlier, like we used to make a very big satellites with multi-purpose payloads. Now we are going for a standalone satellite which will be hardly 25 kg or 200 kg, doing only one specific task for which it is required. As I told you, that this is being used for telecommunication, weather monitoring, etc. Now we are going in the era where satellite will take care of only one function, like either it will be doing telecommunication, or it will be doing intranet, or it will be doing weather monitoring, etc. For that we do not need to make very big satellite. We can go for a smaller satellite, and with that also we will be able to manage with this kind of actuators. You are able to see this is the model of PSLV. This is our workhorse. Started way back in around 20 years, and now we are seeing that it has launched several satellites for India as well as abroad. And this is our satellite which is the highest reliability right now. So anything which we want to send into the outer space, we use PSLV, but it's having a capacity limitation. To overcome that capacity limitation, we have gone for GSLV and then LVM3. And then when you launch vehicle, in launch vehicle we need three things to know. One thing is called rate, second is position, third is velocity. These three things are very much necessary for achieving a correct orbit. Correct orbit means highest lifespan for the satellite. So for that we have a different type of sensors developed by ISRO Initial System Unit. Two type of sensors, one is called accelerometer, second is called gyroscope. So we have a range of accelerometer, like we are having a mechanical accelerometer, is called pendulum based accelerometer. Then we have made for ceramic servo accelerometers, which are being now workhorse, we are using in most of our INS. Coming back to the gyroscope, we have mechanical gyroscope, dynamically tuned gyroscope, then second grade we went for a laser ring gyroscope, and now we are working on MEMS gyroscope, Coriolis resonating gyroscope. These gyroscope and then tuning fork gyroscope. These are the new grade of gyroscope which are being used in all our satellites as well as launch vehicle programs. This is the area which will be giving us the information about the tilt or the position or velocity of it. How to correct it? Correction is done by actuators. So we are developing side by side actuators also. Like you can see that there is a variety of actuator, from nano reaction wheel to momentum wheel, lot of things. Depending on the size of satellites, different type of actuators are developed and they have been used in the satellite. Bigger the satellite, bigger the actuator. Smaller the satellite, smaller actuator. These all actuators are actually put in a quad configuration, so that in all axes it will be able to control the satellite attitude. In this exhibition, this is another thing which we have showcased. This is called SRE, Space Re-Entry Experiment. What is meaning of it? Long back we actually started conceiving the flight of a human in the space. How the human can go and come back from the space. So to know that, to see our capability, the SRE experiment was carried out, and this is containing experimental all the payloads which will give the data required for us to make next generation Gaganyaan. So this was a mission which was successfully carried out, kept in the orbit, and finally it has splashed on the Bay of Bengal. Then it was recovered, and then we have brought it back, and we got all the data required for going for the design of our Gaganyaan process. Main thing is in this is thermal tiles. Thermal tiles are tiles which are ablative in nature. That means they will sacrifice themselves to protect the main capsule. That means they will not allow heat to transfer inside the capsule, main capsule, because when something is coming from the space and entering in the earth gravity, there is a lot of heat is generated. During that heat, everything will melt and vaporized. But the type of ablative tiles what we use, they take care of it, and then we are able to safeguard our capsule. Now we are coming down to here that I have mentioned some time back about our sensors. One I said is a mechanical sensor, this is dynamically tuned gyroscope. This is the dynamically tuned gyroscope, it is a mechanical sensor. Then we graduated to the ring laser gyroscope, which is based on laser principle, the Sagnac effect. And then I said about the cluster. Cluster means one gyroscope will only be able to give you information regarding only one direction. We need to know in all three axes and as well as redundancy. So this kind of clusters are being made. These are made with 3D printing, so that we will be able to mount 6 gyroscope and 6 accelerometer. So ultimately there will be always redundancy will be there. Even if there is a failure of one gyro or one accelerometer, you will be having sufficient knowledge and data available with you to take care of your mission, and mission will not fail. Now I am coming to the prestigious program on which ISRO National Systems Unit is working, that is called Smart Space Robot. Robots are the machine which are doing autonomous work based on the AI or ML, and robot which is meant for working in space. So this is a SSR model which is right now working. It will be having multiple function. One is it will be refueling our old satellite which are in orbit. Second thing, it will be used for debris management. That means the orbit, in orbit there are several satellites which are defunct, now of no use, they are actually debris. So this satellite will catch them and bring back to the earth. Third and foremost operation is, if there is any kind of anomaly in the satellite, this SSR will be in a position to go and repair that satellite, so that satellite's life can be increased beyond whatever we have perceived initially. So here that concept is like that, there will be an OTV, so orbital transfer vehicle, which will be launched. It will be working as a depot. It will be filled with the fuel. Now I will give an analogy that if suppose you want to launch a satellite of 1000 kg class, you may have to put something around 200 kg of fuel to keep it in orbit for next 10 to 15 years. So 100 kg of mass is used only for fuel. If I am in a position to reduce the amount of fuel, that means fuel required for 2 years instead of 10 years, I just only put fuel of 6 to 7 kg, which will be sufficient for 2 years. So I am having availability of 90 kg of mass where I can put additional payloads. So this concept makes us reusable on orbit refueling technology. So these satellites are initially launched with only minimum fuel required to be in orbit. Then this depot OTV, which will be having a huge amount of fuel, will be having the SSR as a chaser inside it. It will be orbiting in the Earth's atmosphere. As and when a satellite is needing fuel, this orbiter will approach that ailing satellites, and from there the chaser, that means a small capsule like this, which will be having 6 to 7 kg of propellant, will approach this ailing satellite, get it docked to the satellite and transfer the fuel to it. As well as if there is any kind of things, some correction has to be made, it will do it, and then it will come back to its mothership, and then this mothership will move to next satellite and search for the satellite, get it docked to that satellite and refuel. So this way we will be able to utilize the 90 kg or 70 kg whatever we have saved in the mass of fuel in the initial time for putting additional payloads, and this satellite can be elongated, their life can be elongated to not only 10 years, 15 years or 20 years or 30 years, as long as we will be able to refuel it. So this is the technology which we are working right now. Like what I talk about SSR or Smart Space Robot, this is the one demo model of SSR. This SSR means this is a system which will be actually operating on the principle of cold gas thruster propulsion, and it is having vision based navigation. That means when it has to dock to the ailing ship and it has to come off of the mothership, it will be initially using the autonomous navigation. As and when it is coming nearer to the ailing ship, it will use vision based navigation, and finally it get docked to it. So this vision based navigation will be used for that purpose, and then it is having a 2 arms. It will go and hold the ailing ship, and then it get docked and transfer the fuel to the ailing ship. As you know that we have already done 2 missions, one to moon and another to the Mars. Now in future we are planning to go to Mars as well as moon, and we are having a plan to land on moon's surface as well as on Mars surface to study what type of soils are there, what type of that habitats are there in that area. On Earth mostly we are seeing that space is already somewhere it is undulations are there, somewhere it is flat or like that. Similarly Martian surface is such a way like that. So initially if a rover has to go, we were planning like a rover with the wheels based. So it may have some kind of obstruction in Martian soil. So for that a quadruped based rover is been planned, which will be initially ejected from the main orbiter in Mars orbiter MOM, and then from there it will be having balloons, and with the balloon it will be landing on the Martian surface. Once it is landing, balloon will get detached out from it, and then this rover will move in the Martian landscape, collect the sample from there, as well as do some studies about the soil quality, moisture quality or water type of temperature, and other parameters is there. Now we are coming back to the best, and whatever is like every Indian is so eager to know about it, is Gaganyaan. Gaganyaan is what? We have already talked about the satellites which are in orbit. We have talked about lot of launch vehicles which are going and delivering the satellite in the orbit. Human in the space, and human also an Indian in space. India is having an ambitious program in which an Indian will be sent to outer space, sitting on an Indian capsule, which will be launched with an Indian launch vehicle like GSLV Mark III, wearing Indian space suit. He will be doing proud all Indians, saying that everything in this mission is been made in India, right? So we are coming back to Gaganyaan. What is Gaganyaan? Gaganyaan is right now our first endeavor to go to the space, outer space, somewhere around 400 km orbit the Earth, do the scientific experiment there, and then come back to Earth safely, carrying this astronaut. But as such, this is a nascent technology and we don't have that much confidence on it. So to do that experiment, we are trying to send a humanoid, a robo which looks like exactly like human, perform all the function of a human, which will be going to the space as a precursor to a real astronaut, collect all the data about the habitat inside that space, what type of vibrations are coming, what type of shock is expecting, what is the pressure inside the capsule, and as well as what type of the tightness of the capsules are there. That means leak tightness. If it is having any kind of leak, life of that astronaut is in danger. So we don't want to take that risk. So initially 2 experimental flights will be sending. We will be sending a humanoid which is exactly like human. It will be able to interact with you. It is working on an AI, so that it is having exactly the artificial intelligence what a human is having. It can talk to people, it can do the experiment whatever a human can do there, as well as it will be able to collect all the data related to the life inside a space capsule. So this will be designed, and it has to be as light as possible, as well as it should have the similar strength a human being having. So for that reason, we have made the parts with the lightest material available, that is aluminum. We have made its lattice structure so that mass is reduced, because carrying a 1 kg mass into space is a very costly affair. So these are similarly the component of its arms. They are also made in organic design. Organic design means exactly like God has made our limbs. This is also made like that. It is having same kind of strength what a human arm limbs is having it, and having a very less weight. So these are all the part of its limbs. So that, and then there are torso. There is a torso. There are eyes movement. It is having ear. It is having speaker to speak to the person. It is able to see it. It is able to react to that what it sees it. So that in next mission it will be a companion to a human astronaut, so that he will be able to interact with the human astronaut and talk as if I am talking to my friend. Now we are coming to the safety aspect of a Gaganyaan mission. What is safety aspect means? Human life is paramount for us. None of the money or anything can take a place of a human life. So our interest is to see that the astronaut which is being sent to the space should be safe throughout its journey. Being it's a launch vehicle, there is possibility of mishaps. Those kind of things happen. Suppose there is any kind of mishap happening here, this is called crew escape system, which we have already tested, and we are going to test few more to see that what really happens in case of a launch vehicle starts its journey from the Earth, goes up, there is some anomaly. So that mission should not cause the life of the astronaut without our intentions. As the path is deviated, this crew module, there is a kind of small rocket here, it will jettison that whole module in the space, and then finally it will come with a parachute and land in a safe Bay of Bengal, so that we can go and recover the Gaganyaan module and bring back the astronaut safely. So this is the part of crew escape system. Now I am coming to, this is the area you call it Gaganyaan. In this there is a cradle. On the cradle, humanoid will be initially in a captivated condition. That means it will be attached to the cradle. As it reaches to the upper atmosphere, it will be allowed to release. Then it will get up. He will be having a screen in front of it. He will be seeing all the command and all the data available to it. he will be able to change the command, he will be able to see the data and analyze and send back to Earth. So this is the prestige mission of India, and we are hoping to start our first mission in this year itself, and hopefully by 24 and or 25 we will be able to send first Indian in the orbit 400 kilometer and orbit us and make us proud that we Indian are also in the race of 4 prime countries like America, Russia and China. Thank you.
So hi everyone, hello. So this is PNT Academy, and like today we are representing our company PNT Robotics. So PNT Robotics is a company which deals with manufacturing and automation solutions, and also we used to provide robotics solutions to various institutes like BARC and then Unilever, Indian Navy. So here are the various projects that has been built by the PNT Robotics. So the first one is a tow robot. So the tow robot has been built during the COVID-19 pandemic to help the COVID warriors or to serve the COVID patients. Then there's the Indian Navy tow watch that has been built. So it has been built by the PNT Robotics itself, and it's the first version of it. And currently we are working on the second version also. And this is a mini humanoid robot. So it's basically a humanoid robot, so it can perform various tasks like dance, exercise, push-ups, and it has total 16 degrees of freedom. So the degrees of freedom means it has a total 16 motors. So it has been connected with a microcontroller, that is a brain, and then we used to control it using a mobile phone. So I will just demonstrate it one of the video. So now it can perform dance. So I will just start a dancing moment. And also it can perform various push-up and exercise movements. So I will just show you one push-up also. Yeah. Okay. So like this it will perform various tasks like dance, and basically it's a pre-programmed robot. So like whatever we program and other requirements are there, so according to that it will program and it will perform that task. And also like through this, like the main purpose of this robot is to like encourage the students of small students like from first standard, 6th standard, to make them explore about robotics or to make them curious about learning robotics. So these are the various model. It's a mini humanoid robot. Then over here it is a Bluetooth control, mobile controlled one, and it's a line follower one. So this model has been built by the students of 4th and 5th grade. So this is our PNT Academy, through which we used to provide robotics courses from 1st standard to the 10th, 11th, 12th. And also for the college students, we are having various internship programs and placement oriented courses for them. So like our goal is to like make them like for the school students, we used to like provide these courses to make them understand about the robotics and latest technology from the early age itself. So this is all about the robotics now. So thanks, that's it.
नमस्कार, मैं डिपार्टमेंट ऑफ एटॉमिक एनर्जी से आया हूँ। हम लोग यहाँ अलग अलग एप्लीकेशंस पे काम करते हैं एटॉमिक एनर्जी के। तो यहाँ पे पावर एक एप्लीकेशन है, ऐसे अलग अलग एप्लीकेशंस है जैसे एग्रीकल्चर में काम करते हैं, फूड टेक्नोलॉजी, वाटर, ऐसे अलग अलग एप्लीकेशन में डिपार्टमेंट ऑफ एटॉमिक एनर्जी काम करता है। ये 700 मेगावाट प्रेशराइज्ड वाटर रिएक्टर का मॉडल है। यहाँ से इलेक्ट्रिसिटी प्रोडक्शन का ये काम करता है। ये जो बिल्डिंग है ये रिएक्टर बिल्डिंग है, ये टरबाइन बिल्डिंग है। यहाँ पे न्यूक्लियर फिशन का हमने यूज़ किया है। एक हेवी एलिमेंट रहता है यूरेनियम जैसा, उसको यदि न्यूट्रॉन से स्ट्राइक करेंगे वो स्प्लिट होगा और चेन रिएक्शन शुरू होगा। चेन रिएक्शन में लॉट्स ऑफ हीट एनर्जी मिलती है। तो ये जो बिल्डिंग है ये है कैलेंड्रिया। यहाँ पे जो फ्यूल यूज़ किया है वो है नेचुरल यूरेनियम। यहाँ पे नेचुरल चेन रिएक्शन शुरू होगा और लॉट्स ऑफ हीट एनर्जी मिलेगी, और वो हीट एनर्जी कैरी करने का काम करेगा हैवी वाटर। हैवी वाटर क्या करेगा, वो हीट भी कैरी करेगा और जो न्यूट्रॉन्स फ्लो हो रहे हैं उसको स्लो डाउन करने का काम करेगा, यानी मॉडरेशन का काम। और वो हीट कैरी करके खुद हीट एब्जॉर्ब करेगा। और यहाँ पे स्टीम जनरेटर है, उसमें ऑर्डिनरी वाटर है, वो खुद हीटअप होगा और ऑर्डिनरी वाटर को हीट एक्सचेंज करेगा। जो हीट एक्सचेंज होने के बाद में ऑर्डिनरी वाटर विल कन्वर्ट इनटू स्टीम, और वो स्टीम से टरबाइन रोटेट करते हैं। टरबाइन के साथ जनरेटर है, जनरेटर इज अ ट्रांसड्यूसर, इट विल कन्वर्ट वन फॉर्म ऑफ एनर्जी इनटू अनदर फॉर्म ऑफ एनर्जी। तो मैकेनिकल एनर्जी को इलेक्ट्रिकल एनर्जी में जनरेटर कन्वर्ट करेगा। तो ये यहाँ का प्रिंसिपल है।